This video is going to demonstrate how X-ray photons are produced by Brems and characteristic interactions. As we know, X-ray photons are produced in the X-ray tube. It's produced when the electrons are traveling from the negative side, which is the cathode side, and it goes into the positive side, the anode side. We know that what happens is when the filaments are heated up, it produces the electrons. Then what happens is the focusing cup is then going to make the electrons move at a speed of light to hit the target. This target, remember, is made out of tungsten. Okay, this is where Brems and characteristic interactions produces X-ray photons. Oops. So let's take a look at the Brems. Now, if we were to look at the Brems of the atoms, we know that the incident electrons is now going to try to target the nucleus. So the incident electron will be traveling, but then what's going to happen once it reaches the force field of the nucleus is it is going to break. That's where the term Brems comes from, is break. Once it reaches the nucleus force field, it's going to change direction. This loss of energy, this change of direction, is what produces the X-ray photon. Again, the electron is going to try to aim for the nucleus. No change directions. Now the sharper this angle is, the more high energy X-ray photon it produces. Also, remember that in Brems, if it is below 70 kVp, 100% is Brems. If it is above 70 kVp, 85% is Brems. And we're going to learn about the other 15%, which is the other interactions, and that is the characteristic. So in the characteristic, interaction, what's going to happen is the incident electron is going to shoot towards the K shell. So here we have the K shell, L, M, N, O, and P. Remember, this incident electron has to be as equal or higher than the K shell electron of the energy, which of course it has to be at least 69.5 keV. So it's going to go traveling, and it's going to bump this one out. Now what's going to happen is, once the K shell electron is ejected out, the electrons from the L will now fill in the K, M will fill in the L, N fills in the M, O goes in the N, and so forth. And this is where the energy difference is emitted as an X-ray photon. So now these are X-ray photons. Remember, with characteristic, if it is below 70 kVp, 0% is characteristic. If it is above 70 kVp, 15% is characteristic. And that is how X-ray photons are produced. Electrons are moving from the negative side to the positive side. Electrons are filled from the filament that hits the target, which is made of tungsten. And that's where the X-ray photons are produced.